Good morning, students. Once again, I welcome you to my video lectures on control systems. So, next guide I am going to take up is what is known as angle of asymptote calculation. Angle of asymptote calculation. So, this calculation need not come in all problems on control systems. Only when a set of branches terminate at infinity, this calculation is supposed to be carried out. Otherwise, asymptotic calculation, angle calculation is not required. Angle of asymptote. What is this angle of asymptote? I will explain. First, you look into open loop transfer function Gshs. Gshs is what is called as open loop transfer function. Gshs is what is called as open loop transfer function, where there are m number of zeros and n number of poles. M number of zeros and n number of poles. As you all know that the number of branches of the root locus is always equal to the number of poles. So n number of poles, n number of branches. M is number of zeros. M is number of zeros. If m is less than n, then n minus m branches, they terminate at infinity. Suppose if m is 0, there are no zeros at all, then all the branches terminate at infinity. Therefore, if there are n number of poles and m number of zeros for a open loop transfer function, then n minus m branches terminate at infinity. So for these branches, you are supposed to calculate what is known as angle of asymptote. I will also remind you the problem. First, I will go through the guide 4. The loci which terminate at infinity approach asymptotes. In doing so, a knowledge of these asymptotes is helpful in defining the general appearance of a root locus plot. It is called angle of asymptote phi a, given by phi a is equal to 2q plus 1 into 180 degrees divided by m minus n, where m is number of zeros of open loop transfer function and n is number of poles of open loop transfer function. I will explain in detail. Now, I would like to remind you problem Gshs equals k over s into s plus 6. This was the problem. And in this problem, there are two poles at s equal to 0 and at s equal to minus 6. And in this problem, the root locus will look like this. And one branch, both the branches, there are two branches because there are two poles. And two branches, they terminate at infinity. And if you observe the direction, they are going at 90 degrees. They are essentially going through 90 degrees. For example, this branch is going at an angle of plus 90 degrees because plus angle is measured in anti-clockwise direction. So at plus 90 degrees. So this is 90 degrees. This is minus 90 degrees. So plus 90 degree and minus 90 degree, they are called as angle of asymptotes, as there are two branches. Therefore, these angles are called asymptote angles. So now I will going to give you a formula. I will going to derive the formula for this angle of asymptote. Now for example, take a general problem. And in this problem, you take a set of poles and zeros. You take set of poles, zeros. When you take a set of poles and zeros, and we are supposed to calculate the angle of asymptote. That means at what angle it proceeds towards infinity. Therefore, trial point is to be taken. The trial point is to be taken at infinity. When you take trial point at infinity, as you all know that, for example, this is a pole P1, this is a pole P2, this is a 0 Z1, this is a 0 Z2. So on taking the trial point, imagine that this trial point is at infinity. So we have to join. Now we have to join these points. When the trial point is at a far off distance, so you can imagine that these lines are parallel. This is possible only when the trial point is at infinity. Now, these are all parallel. These are all parallel. Now, what I will do is, when these are all parallel, I will take these angles as alpha. Then, what is the condition? Angle criterion. Angle criterion is summation theta z minus summation theta p is equal to 2q plus 1 times 180 degree. This is what is called as angle criterion. So these angles, summation of these angles. So for zeros we have to take with plus sign, and for the poles we have to take with minus sign. It has to be equal to 2q plus 1 times 180 degrees. Now, as the trial point is at a far off distance, these phases run parallel. What is this length? This length is s plus p1. This is s plus z2. This is s plus p2. This is s plus z1. Now, I am interested only in the angles. Now I can take for this summation theta z as m times alpha. So m is number of zeros of Gshs. So number of zeros are m in number. Therefore, total angle contributed by zeros is m times alpha. Next, minus n times alpha, because I have to take it for poles. So for poles it is n times alpha equal to 2q plus 1 times 180 degrees. Therefore alpha is equal to 2q plus 1 times 180 degrees divided by m minus n. That is, Gshs will be of this form: s plus z1, s plus z2 divided by s plus p1, s plus p2, etc. S plus z1 contributes an angle alpha. S plus z2 contributes an angle alpha. So that is why I have taken here m alpha minus n alpha equal to 2q plus 1, 180 degrees. And this is a very important formula. So the important formula for angle of asymptote is alpha a. Normally we don't use alpha sign, we use plus sign or phi sign. Phi a. Angle of asymptote. Angle of asymptote is equal to 2q plus 1, 180 degrees minus divided by m minus n. Now, I will take few examples. Gshs equals k over s into s plus 6. K over s into s plus 6. Here, the number of zeros is equal to 0. Number of poles is equal to 2. Number of poles is equal to 2. Therefore, there are two branches that terminate at infinity. Therefore, we have to calculate phi a1 and phi a2. Phi a1 and phi a2. So, formula is phi a calculation is 2q plus 1, 180 degrees divided by m minus n. Divided by m minus n. First, phi a1. Phi a1 is equal to, take q equal to 0. Take q equal to 0. Therefore, 180 degree divided by 0 minus 2, because there are two number of poles. Therefore, it is minus 90 degrees. Minus 90 degrees. Next, phi a2. Phi a2 is equal to 180 degree divided by 180 degree divided by. Now here we have to take q equal to 1. If you have to take q equal to 1, that is 2 plus 1, that is 3, divided by minus 2, that is minus 270 degrees. Minus 270 degrees. Therefore, phi a1 is minus 90 degree, phi a2 is minus 270 degree. That is, later I will show you how to mark this angle. For the time being, we just calculate phi a1 is equal to minus 90. Minus 90 means angle measured in clockwise direction. So phi a1 is minus 90 degrees and phi a2 is minus 270 degrees. Minus 270 degrees. Minus 270 degrees. Now, in the next class, I will show you how to mark this angle phi a1, phi a2. Phi a1, phi a2 angles are marked at a point called centroid. Centroid is to be marked, and after marking the centroid, we have to measure these angles, what are known as angle of asymptotes. Thank you.